So good morning everybody, myself Acharya Vishvendra and discuss a worksheet on a spring mass system. Let's begin with the worksheet. So here is the worksheet on a spring mass system. Spring of stiffness K is attached to a block of mass M and it is pulled to the left by a distance capital and released from rest. Then find initial force. So force is equal to Kx, direction will be rightward, so the force will be K. Initial acceleration, force is equal to Ma. So acceleration comes out to be Ka by M. Next is initial velocity at it is released from rest. So initial velocity is 0. Next is take origin at O, find acceleration as a function of x. So force is minus kx, so acceleration will be minus kx by m. Next is which type of motion is executed by the block. So it is SHM. Next is find xt relation. So as particle starts moving from the left extreme, so the equation is x sine x is equal to a sine omega t plus 3 pi by 2, which is equivalent to minus a cos omega t. Next is find Vt relation. So V is equal to a omega cos omega t plus 3 pi by 2. So it is a omega sin omega t. Next is find At relation. So A is equal to minus a omega square sin omega t plus 3 pi by 2, which is a omega square cos omega t. Next is draw xt graph. So xt graph will be like this. Then draw Vt graph, it will be like this. At graph will be like this. Kinetic energy is sin square graph, it will be like this. Next is find time period of small oscillations. So the first question is here is simple block. So time period is 2 pi root m by k. In the second question, the two springs are in series. So replace k by k equivalent, which is k1 k2 by k1 plus k2. So that will be the time period. Here the two blocks are in springs are in parallel. So that will be the answer. Here all the springs, both the springs are in parallel. So that will be 2 pi root m by k1 plus k2. Here all the three springs are in parallel, so 2 pi root m by k1 plus k2 plus k3. Here also all the springs are in parallel, so that will be the answer. Here all the springs are in parallel, so we have 2 pi root m by that is going to be 6k. Next is here these two springs are in series and this is in parallel with this. So the equivalent of these two springs will be 2k by 3 and it is 3k. So we just add up these things and it will be equal to 2 pi root m by 11k by 3. So that will be 3m by 11k, which is the time period of this system. Next, here all the three springs are in parallel. So we have k equivalent as 2k plus 3k plus 4k, which is 9k. So that is going to be the time period for this.